Good morning, students. Myself is Srinivas, Assistant Professor, Department of ECE, Kakatiya Institute of Technology and Science, Warangal. Welcome to video lecture on Microwave and Optical Fiber Communications, subject code UE18EC 702C. Topic: Power output and efficiency of reflex klystron oscillator. In the last class, we discussed about the construction and operation of reflex klystron oscillator. In that, the electrons are generated by the electron beam affected by the noisy voltage which is present in the cavity, penetrates into the repeller and comes back towards the cavity for the second time. The operation of reflex klystron oscillator is explained based on Applegate diagram. This is the Applegate diagram where the bunching is formed at 1 3/4 cycles from the center of cavity gap. And that is the case for dominant mode. And for the remaining modes, the bunching can be formed at 2 3/4 cycles or at 3 3/4 cycles or at 4 3/4 cycles. That is for the practical oscillations are possible up to small n is equal to 7. The power output and efficiency. This is the equivalent circuit of reflex klystron oscillator. The fundamental component of induced current in the catcher cavity is given by small I2 induced is equal to beta naught I2 beta naught 2 I naught J1 of x dash e power minus j theta naught dash. This particular equation is similar to the equation which we already derived in reflex klystron oscillator. The only difference is dash bunching parameter x dash and gap transit angle theta naught dash. In klystron it is x and theta naught. In reflex klystron it is x dash and theta naught dash. That is the only difference. The magnitude of induced current is given by uh, capital I2 induced. It is a magnitude of this particular I2. Beta naught I2, beta naught 2 I naught J1 of x dash given by equation number 2, where I2 is equal to I naught J1 of x dash, equation number 3. Here x dash is the bunching length in reflex klystron oscillator. J1 of x dash is the Bessel function, and theta naught dash is omega t naught dash, that is round trip transit time to n pi, that is 2 pi n minus 1 by 4, and that is equal to n pi minus pi by 2. This particular equation we already discussed in the previous lecture. Here in equivalent circuit, GB, beam loading conductance, copper loss of cavity, effective shunt resistance. Now here it is once again, I wrote equation number 4, and reflex klystron is a single cavity oscillator. This is the position of T0 and T1 and once again T2. T0 is the time for the electron to enter the cavity, and T1 is electron to leave the cavity, and this particular electron is repelled by the repeller, comes back towards the cavity and reaches at time T2. That is V1 is the voltage at T1, V2 is the voltage at V2, and V2 is equal to V1 e power minus j pi by 2. Here if we observe the magnitudes, the magnitude of V1 and the magnitude of V2 both are same with some phase difference. That is here V1 2 I naught beta naught theta naught x dash, beam coupling coefficient, transit angle, bunching parameter. V0 is the applied DC voltage. And theta naught dash is 2n pi minus pi by 2. The DC input power is given by the DC current I0 and DC supply voltage I0. AC input power, that is beta naught I2 V1 by 2, and this can be simplified as equation numbers 9, 10 and 11, and substituting equations 7 and 11. Substituting equation 7 and 11 in efficiency, that is efficiency eta is equal P out by P in. It is given by equation number 12. It is, and here for maximum theoretical efficiency, we have to consider the values of x dash j1 of x dash as the maximum value is around 1.25, the product maximum value, and here n is equal to, that is 1 3 by 4 mode. By substituting all the maximum values, we get the maximum theoretical efficiency would be 22.7, and actually it is around 10 to 20% in practical case. The next is relation between repeller voltage and anode voltage. Here this is the anode voltage, sorry, this is the cathode voltage V0, and this is the repeller voltage VR. What is the relation between these two? In case of reflex klystron oscillator, V0 is the DC voltage applied between electron gun and anode, and VR is the repeller voltage applied between cavity gap and repeller. The relation is as follows: V0 by VR minus V0 square is equal to 2n pi minus 5 by 2 square E by M 1 by 8 omega square L square. You just go through the derivation available in textbook Kulkarni, pages 323 to 326. Here once again I mentioned the time T0, T1 and T2. The next is electronic admittance. Once again here I am taking equation number 1. The fundamental component of induced current in the catcher cavity is I2 given by equation number 1, and V2 is the voltage at V2 is the voltage at time T2, V1 is the voltage at time T1. The relation is V2 is equal to V1 e power minus j pi by 2. Let it be equation number 13, and the ratio of small I2 induced to V2 is defined as the electronic admittance of reflex klystron amplifier. That is, by taking the ratios of equation number 1 and 13, we get equation number 14, and after simplification, uh, we get the value of the formula for electronic admittance is given in equation number 15, that is simplified equation. Thank you. We will meet with the next lecture.